Stoichiometry, limiting reagents, and excess reagents. That's what we're going to cover in this problem. But first, we need to balance this equation. We can do that by putting a 2 right there because the magnesiums are already balanced and there's twice as much hydrogen and chlorine from the H2 and Cl2 on the right side. So the coefficients are going to be 1, 2, 1, and 1. Get that a little closer to the H. So in this problem, they're giving you a certain amount of HCl right there. That's a reactant. And then a certain amount of magnesium, which is another reactant. All right. They're not even asking you for the product, so it doesn't even matter what's on the right side. They are asking you to figure out which one of these is going to run out first. All right. So it's like, hey, I have a certain amount of table legs and a certain amount of table tops, and I want to make tables, and or frames and wheels, and I want to make bicycles, and that kind of problem. Which one am I going to run out first? Now this one is not too hard to see. I don't even need to do any work to answer this question because according to the recipe, according to the balanced equation, you need twice as much hydrochloric acid than you do magnesium. And although you can't compare grams to grams because they have different molar masses, it's not even close. This is, I mean, this is about, 36 is the molar mass there, and this is like 24, so they're not too far off. All right, and this number needs to be, there needs to be twice as many moles of that. So, all right, anyway, I might be misleading you here because we're not supposed to compare grams to grams, and that's kind of what I'm trying to estimate. But the whole point of that was to estimate the moles. All right. I don't know. I feel like I just confused you. If that was confusing, just start here. Okay, let's do HCl in blue. We'll do that. So we need to convert to moles. That's what's important. Once we have it in moles, then we know precisely how they're related. It's an exact relationship, 2 to 1. All right. Now these grams you can't really use to compare. Not precisely, at least. All right, so 6.00 grams of HCl is what we're given, and we want to convert that to moles because then we can precisely compare the two. All right, so if it didn't ask anything else, I would just round these numbers. Like HCl, I would just round to like 36.5 or something like that, but I can see it's asking me to calculate something later. So, all right. So H is hydrogen. Let's take this out to 4 digits because we're going to do calculations later that requires 3 digits of sig fig. So I'm going to take this out to 4 digits. Chlorine is over here, by the way. 35.45. Add them up. 35.458 grams per mole is the molar mass for hydrochloric acid, 35.458. What? Oh, sorry. That's just chlorine. I gotta add the 1 for the hydrogen. 35 point. Keep saying 35. 36.458. All right, no more mistakes. The rest of the year. Okay. 36.458 grams of HCl per 1 mole of HCl. That's called the molar mass, and we use that as a conversion factor anytime we need to convert between mass and moles, or moles and mass. All right, calculator, punch it in. 6 divided by 36.458. Whew, spicy. 0.16. I'm going to round here. No, I'm not going to round because I'm. This is not any kind of final answer, so I'm going to need these numbers later to be precise. So I'm going to take it out the 4 digits. 0.1646. All right. Then I don't have to worry about looking up numbers on my calculator later. Calculator later. Calculator later. Calculator later. Alligator. Oh, okay. So this is how many moles of HCl we have in this reaction. I'm going to do the same thing with the magnesium. All right, so we got 5.00 grams of magnesium. We need to convert that into moles. And I'm going to use 4 digits again. Magnesium is right there, 2431. 24.31 grams of magnesium to 1 mole of magnesium, molar mass, used to convert between mass and moles. All right, punch, punch. 5 divided by 24.31. 0.2057. We'll leave it there. 4 digits. Moles of magnesium. All right, now you tell me, what is the limiting reagent? It should be very apparent. Did you say HCl? Well, you're correct. Hydrochloric acid is the limiting reagent. Now, did you say it's HCl because it has a smaller number of moles? Well, that's the wrong reason. All right, you can't do that. You can't just, because they're not the same ratio. It's a 2-to-1 ratio, right? But that makes it even more obvious, because here you're supposed to have twice as much HCl as magnesium, and you don't even have equal amounts. So this is by far going to, a hydrochloric acid is going to run out much earlier. It's not even close. All right, you would need half of this, which is 0.08, and this is way more. So you're going to have a lot of magnesium left over. So this is, the magnesium is the leftover substance. It's going to be the excess reagent, right? And whoever set this up is a bad chemist. They're awful. They just wasted more than half of their magnesium, or it's just going to be left over. So let's figure out exactly how much that is, because that's the last part of this question. How much of that magnesium is left over? All right, that's why we save these 4 digits in our calculations, because now it's asking us to calculate the mass. What mass? All right, so here's the plan, and there's a couple ways you can do this, but here's the plan that I'm going to go with. This is going to run out first. We have tons of this stuff left over, magnesium. So we want to figure out how much of the magnesium is actually going to get used by the HCl, or with the HCl. All right, if we can do that, the rest of it is left over. The rest of it is the answer. All right, hope that makes sense. All right, so we'll just use these numbers, right? So 0.1646 moles of HCl. Right? Well, already it's only going to use up half of that, because you need twice as much of it. All right. Anyway, I want to show my work so you can see it that way. All right. So it's 2 moles of HCl per 1 mole of magnesium. We need twice as much of this. All right. We know that because the balanced equation tells us that. All right. So these cancel out. And then you're going to get just half of that, which is 0.1646 divided by 2 is, like I said earlier, is 0.0823 moles of magnesium. Right? That makes sense, because that is half of that. Or you can say 0.164 is twice as much as 0.8 or 0.0823. Right? We have 2 times as much here as we do here. Right, that's what it's supposed to be. So if we had this much HCl, it would exactly use up that much magnesium. All right, but we started with a ton more. So we're just going to subtract from that starting amount right there, that amount given in the beginning, how much we actually used, and then the rest is left over. So 0.2057, all right, moles of magnesium was originally given, and in this reaction, only 0.0823 moles of magnesium was used. So it's going to be 4, 3, 2, 4, 3, 2, 1, right? Moles of magnesium left over. But it's not asking for moles, it's asking for mass. Whew, that's a long problem. All right, well, we know how to do that. Moles to mass, molar mass. Get rid of moles, get mass. All right, we did this earlier, so it was like 24 point, let me see it again, 24.31. Cancel, cancel. 0.1234 times 24.31, 3 grams left over. 3.00 grams of magnesium left over. Wasteful. Didn't even use half of it. Bad stoichiometry chemist.